This is a video on the type 1. That means that x is approaching a number, the type 1 limit of a piecewise function. Now remember that a piecewise function always has this curvy bracket. And we see that x squared is what we use when x is less than -1. And here's the graph of x squared, but only where x is less than -1. And when x is greater than or equal to -1, we use the function just x, y equals x. And that's the graph of y equals x. Now I always recommend that we draw a number line to indicate what functions we're using and where. So -1 is where we change functions. And when we're less than -1, we're using this function x squared. So we write x squared in this region. And greater than -1, we use the function x. So we write in x in this region. Okay, in this problem, we're approaching, x is approaching 1. And notice that it's the two-sided limit. So let's go ahead and put in our values of 1 and 2. That's where our functions change in the piecewise function. When x is less than 1, we're using 5 minus x. When x is between 1 and 2, we're using 4. And greater than 2, we're using 2x plus 1. Now we're going to write, because this is the two-sided limit, we're going to write each of the one-sided limits and evaluate them. So as x approaches 1 from the left and 1 from the right of g of x. Now, as x approaches 1 from the left, the question is, what function would we be using? Well, we'd be using 5 minus x. So we write the limit as x approaches 1 from the left of 5 minus x. What about as we approach 1 from the right side? What do we use for g of x when we're approaching 1 on the right side of 1, very close to 1? The answer to that is we use the value 4. It's a constant. So to evaluate the limit, the left-hand limit, we replace x with a 1, and the limit of a constant is equal to itself. So we have 4 equals 4. The left-hand limit equals the right-hand limit, and the two-sided limit is also equal to 4. Now we have to write a reason why this is true. And we write because the left-hand limit of g of x is equal to the right-hand limit of g of x. And the order in which you write that doesn't matter. Okay, now this is a 9-point grading rubric. So if you have a free response question like this and you want to get all 9 points, this is what you've got to do. The first point you're going to get is from writing in this number line. We have our values 1 and 2. When we're less than 1, g of x is using 5 minus x. Filling out this number line gains you the first point. And we're going to label all of the points that come up in this problem. Next, because this is the two-sided limit, we need to write down each of the one-sided limits, and each of these is 1 point. X approaches 2 from the right side of g of x, and x approaches 2 from the left side of g of x. So each of those are 1 points. Now, our next 2 points come from replacing g of x with the appropriate function. So approaching 2 from the right, we would be using 2x plus 1. Again, we've got to maintain the limit notation here. If you don't write in the limit notation, you won't gain or earn those points. Approaching 2 from the left side, we're using the function or the constant 4. And here we circle these two values and write in and indicate that they're not equal. So here's a point for replacing g of x in both the one-sided limits, and now a point for indicating that the two one-sided limits are not equal. Now we go back to the original problem and say that the limit as x approaches 2 of g of x does not exist. And we give a reason why, because the left-hand limit did not equal the right-hand limit. Again, you've got to use the proper notation 1 point for this and 2 points here. So the total here is a total of 9 points.